Let's do number 7. So, a 5 foot tall woman walks towards a street light that is 20 feet above the ground. So, let's get our situation going here. So, we have this street light, and this street light, we are told, is 20 feet. Then we have this woman, and I'm gonna, due to my lack of drawing skills, I'm gonna draw this right off the bat. I'm gonna draw the woman in purple. So we have this woman who is 5 feet tall. Okay? And she is walking towards, she is walking towards the street light at a rate of 8 feet per second. So I'm going to call the distance that the woman is from the street light, so this distance right here, I'm going to call it X. I'm going to call the length of the woman's shadow, which I'll do in a different color, I'm going to call that Y. Okay? So we are told that she is walking towards the lamppost or the street light, which means we are looking at the change in X, because that change in X is getting smaller. So we get dx dt equals -8 feet per second. So the first thing they want us to do is they want us to find the rate of change of the length of the shadow. So in other words, we want to find what is dy dt. So we want to find, I'm going to put it up over here. We want to find out what is dy dt when she is 15 feet from the light. Yes, so what is the rate of change of the length of her shadow when she's 15 feet from the light? Then there's a second question. Second question is, at what rate is the tip of her shadow moving? So I'm going to take care of question number 1. So question number 1 again is, what is the rate of change of the length of her shadow, which again I've defined as y. So I'm going to need an equation that relates x and y. In this case, I'm going to use similar triangles. So I'm going to say that 20, the big triangle, which is 20, is to x plus y, as the small triangle, 5, is to y. And I'm going to kind of number these so it's easier to refer to. So I'm going to call this equation number 1. Okay, let's go through and simplify this a bit. I'd like to clean this up a little bit. So let's see what we got here. So in this case, I have 20y equals 5x plus 5y. Dividing everything by 5, I get 4y equals x plus y. And moving that y over, I get 3y equals x. Okay. I have a function here, and I'm going to call that, let me call that function number 2. Next, I want to find the change in y. So in order to find the change in y with respect to time, it is time to take a derivative of my function. So let's do that. So I get 3 times dy dt equals dx dt. In order to find dy dt, I am going to multiply both sides by 1/3. And so I get 1/3 times dx dt, which means that dy dt equals 1/3. dx dt was -8, so it's 1/3 times -8 feet per second. Okay, so that is the rate of change of the length of her shadow. Next, actually, let me just put this in here just in case I need it. I don't know if I'm going to need this any further, but just in case. I'm also going to label this 4 because I know I'm going to need that. Now let's talk about the tip of the shadow. So let's kind of go back to the drawing here. So in this case, the tip of the shadow, we want to find the tip of the shadow. So we're trying to find it for question 2. I'm trying to think of a good way of saying this. For question 2, I want to find, for this is the tip of the shadow, what is its rate of change? Well, if you think about it, this question is really asking for what is the rate of change of the distance from, and I'm going to highlight this in pink, what is the rate of change of this distance right here? Because that gives me from base to tip of shadow. So they're really asking what is the rate of change of that length? So let's think about that for a second. Well, that length, I think you guys would agree, is x plus y. So I'm calling just, again, the length, I'm calling L. L is going to be equal to that highlighted pink portion, okay? And it equals x plus y. If I want to find the rate of change of L, then I have to take the derivative, take the derivative. So dl dt equals dx dt plus dy dt. And the nice thing is we already have numbers for these. dx dt we were given is -8. And dy dt we found in equation 4. So dy dt equals plus 1/3 times -8. So, and that is the rate of change of the tip of the lamp, and I'm going to put that in feet per second. Okay, let's see here. Let's do one more video. One more. Let's do one more. I'm going to pause this and I'm going to break it up here because I think the next one is a little bit long.